It's great to be together once again. I hope everything is well with you. The James Webb Space Telescope is one of the primary tools scientists use to explore the mysteries of our universe. In operation since the end of 2021, it has already justified the $10 billion invested in its construction, with numerous advancements made possible by its advanced technology. At the same time, the Hubble telescope, considered its predecessor, continues to contribute significantly to our knowledge about the cosmos, including its age, size, and expansion rate. So, what would happen if we combined these two instruments? The answer is simple: a revolution. In today's video, we will present a significant discovery that can be achieved by uniting these powerful tools. It might sound like an exaggeration, but believe me, the results from these investigations have caused a significant crisis in cosmology, likely to transform our current understanding of the universe. It's an exciting time to be alive, and it's a great pleasure to share this with you. So, stay with us as we explore the latest groundbreaking evidence produced by the James Webb Telescope. We'll start with the observation of exoplanet TOI 270d, located 70 light-years from Earth. This planet has characteristics never seen before, such as a potential ocean of liquid water at 100 degrees Celsius. I know it sounds strange, but let's try to understand it better. TOI 270d is about 5 times more massive than our planet and is only 7% of the distance that separates Earth from the Sun. This may seem very close, but its star is a red dwarf with temperatures between 2,400 to 3,700 degrees Celsius, unlike the 5,000 to 6,000 degrees Celsius of our yellow dwarf star. Additionally, it takes just 11 days to orbit its sun, meaning seasons and years pass much faster there. This proximity to its host star causes a phenomenon known as tidal locking, similar to what happens with our moon. Due to gravitational attraction, the planet does not rotate on its axis, always showing the same face to the sun, resulting in perpetual daylight on one side and eternal night on the other. This has led to the development of an atmosphere very different from ours, with significantly higher pressure, allowing water to exist in a liquid state at higher temperatures. These findings were produced by a team of astronomers from the University of Cambridge and published in the journal Astronomy and Astrophysics. According to them, despite TOI 270d's extreme conditions, it might still support life, particularly on its cooler dark side, which could have a temperate ocean with an average temperature of 20 degrees Celsius. Combined with an atmosphere, this could mean the presence of life. However, not everyone agrees with these findings. A group of researchers from Canadian and American institutions has submitted a paper for review, challenging the British team's results. These investigations are delicate, as the planet is very far away, and analyses are based on color spectrum variations caused by the atmosphere when the planet passes in front of its star. This process is complex and sensitive, subject to varied interpretations. According to this new group, TOI 270d's surface temperatures could easily exceed 4,000 degrees Celsius, making liquid water impossible even under extreme pressures. This might be disappointing for those hopeful of finding life on another planet, but it remains incredible to investigate such a distant object so revolutionarily. A similar event occurred in a publication made recently at the end of March this year by a team investigating a well-known solar system, TRAPPIST-1. Located just 40 light-years from Earth, this system has a star very similar to the one we just discussed, a red dwarf. The scientific world turned its attention to this publication because there was great hope that the planet being investigated, TRAPPIST-1b, might have conditions to develop or host life, as it is quite similar to Earth. However, it is the closest planet to the star, and even though the star is smaller, its temperatures are very high, exceeding 230 degrees Celsius. Under these conditions, it is unlikely that TRAPPIST-1b has an atmosphere. Despite this pessimistic note, the publication also highlighted that other planets in the same solar system are even more promising but have not yet been adequately investigated. This is the case for TRAPPIST-1e, 1f, and 1g, which are also similar to our planet and lie within the habitable zone of their star, where temperature, pressure, and gravity conditions might be more favorable for the emergence of life. We are eager to learn about the next chapters of these investigations. Another incredible achievement provided by the James Webb Space Telescope was the images of the nebula NGC 604, located in the galaxy M33, about 3 million light-years from Earth. This is an impressive feat because nebulae like these are considered star nurseries, where stars are formed. NGC 604 is absolutely massive, with a diameter of about 1,300 light-years, much larger than the 40 light-years of the Orion Nebula, the closest stellar nursery to Earth. The colors obtained by the telescope revealed that the gas cloud contains ionized hydrogen, polycyclic aromatic hydrocarbons, and molecular hydrogen, essential substances for producing new stars, which act like power plants fusing elements, primarily hydrogen. However, some researchers believe that the nebula might also contain acetic acid, formic acid, ethanol, and methanol, much more complex substances that could be related to the potential emergence of life or at least the conditions necessary for it to occur. The results are still preliminary and require further review, but it is nonetheless exciting to know that this is happening, and a significant revelation could emerge at any moment. But nothing we have discussed so far compares to the next revelations we are about to present. These are confirmed and promise to change everything we know about the origin and composition of our universe. Starting with the discovery of ZFUDS 7329, which is already being called the Impossible Galaxy. This cluster of planets and stars was discovered at least 10 years ago, but it was only with observations from the James Webb Space Telescope that researchers could truly understand its nature. Thanks to the advanced technology of this new telescope, it was determined that the galaxy is at least 11.5 billion light-years away. Given that looking into deep space is essentially looking back in time due to the time light takes to reach us, it is safe to say this galaxy is at least 13 billion years old. At first glance, this may not seem problematic, but ZFUDS 7329 is extremely massive and nearly twice the size and star count of the Milky Way. This is astonishing because forming a galaxy of this size typically requires billions of years, yet data suggests the galaxy formed when the universe was just 800 million years old, a period when it was still young and in the early stages of expansion and cooling. Current understanding posits that the formation of such large galaxies necessitates the influence of dark matter, a type of matter that only interacts through gravity, not with normal matter or even itself. This gravitational interaction allows for the coalescence of components into nebulas, stars, planets, and the systems we know. However, this process takes billions of years. Moreover, dark matter did not emerge immediately with the Big Bang but took a long time to form, making its presence at that early time unlikely. Therefore, ZFUDS 7329 should not exist under our current understanding, hence its nickname, the Impossible Galaxy. Its existence can only be explained in two plausible ways. The first is that our observational and measurement instruments are flawed, causing unreliable data and resulting anomalies. While this might have been possible with older telescopes, the James Webb is highly precise, and its data has been checked multiple times by different experts. If there is an error, it has yet to be found. The second, more widely accepted explanation is that our understanding of galaxy, star, and dark matter formation is incorrect or incomplete. We might be on the brink of a major revolution that could alter everything we know. This would account for the disparity between collected data and existing theories, which no longer seem to fit. Are you impressed? Wait until you hear about our next discovery. Since the universe has existed, pay attention, the space within it has been expanding. This has been happening for at least 13.8 billion years, according to the leading theories. The rate that measures this expansion is known as the Hubble constant, named after the physicist who also gave his name to the telescope and dedicated his life to studying the cosmos. This constant is one of the most important measurements we have, as it allows us to calculate the age of the universe, its size, the influence of mysterious dark energy that drives the expansion of space, and even intergalactic distances. On large scales, space dilation must be considered to plot a trajectory or make precise measurements. However, there's a small problem. There are at least two reliable methods to calculate the Hubble constant, and for years they have produced different results for reasons still unknown. This phenomenon is called the Hubble tension and is one of the biggest crises in modern cosmology. Unlike most units of measurement, the constant that measures the expansion rate of the universe has three variables: kilometers per second per megaparsec. The first two are more familiar and are used to calculate velocities from distance and time data. The last one is used because the expansion is constantly accelerating, with a base value of 3.3 million light-years for 1 megaparsec. Let's set aside the formulas and focus on the methods used to obtain the current values. As we said, there are basically two: the standard ruler method and the standard candle method. Let's understand them simply. The standard ruler method uses the cosmic microwave background, CMB, radiation as a base, which is the afterglow of the first light escaping from the plasma fog after the Big Bang when the universe was only 380,000 years old. This happened a long time ago, but as we mentioned, looking into deep space is observing the past because light takes time to reach us. The information obtained by this method indicates that the Hubble constant is about 67 kilometers per second per megaparsec. The standard candle method, on the other hand, uses the brightness of certain stars or supernovae as distance references. These are known as Cepheid variables and have the characteristic of emitting light at constant intervals, pulsing rhythmically. This method is generally used to measure the expansion of the local universe and produces a value of 74 kilometers per second per megaparsec for the Hubble constant. Even though all this may seem complex, what we need to remember is that two absolutely reliable parameters for measuring a quantity are still producing different results, even though they theoretically analyze the same phenomenon. It's like two speedometers showing different values for a car traveling the same distance at a constant speed. This makes it easier to understand. Something must be wrong, whether it's the calibration of the equipment, the path taken, or the formula used. In the case of the Hubble constant, the issues could be attributed to the equipment used, such as the Hubble telescope itself, some unknown property of dark matter, or our understanding of the universe, which might be flawed. Until recently, it was thought that the error was due to the Hubble telescope, as it is old and quite limited, despite its invaluable contributions. This is where the James Webb Telescope comes in. This new telescope, being more modern and precise, makes observations in the infrared spectrum of light, providing an excellent comparison to the visible light data from Hubble. Scientists hope to combine these technologies and demonstrate that the James Webb is more accurate, correcting any errors. But, unfortunately, or fortunately, that's not what happened. The new measurements confirmed the data produced by the Hubble telescope, nearly eliminating the possibility that the difference was due to a measurement error. Instead, it suggests a fundamental misunderstanding of the universe. This result did not discourage scientists. Instead, it created great excitement, as it indicates that we may be on the brink of a revolution in our understanding. One of the first attempts to address this comes from the efforts of theoretical physicist Rajendra Gupta from the University of Canada. He recently published an article claiming that our estimates that the universe is 13.8 billion years old, expanding at a rate of 74 kilometers per second per megaparsec, are incorrect, potentially confirmed by the new discoveries of the James Webb. According to Gupta, our current data were calculated based on a light trick that hid the true information about the universe, including its age. He suggests that the cosmos is more likely around 26.7 billion years old, almost twice what was previously thought, and that dark matter, believed to play a fundamental role in expansion, might not even exist. Its role could be explained by the weakening of the fundamental forces of nature. However, it is still too early to test the validity of this hypothesis. The studies are recent, and a series of experiments will be necessary to verify the authenticity of this new theory. But one thing is certain: the world, the stars, galaxies, and everything that makes up the universe is not functioning as we imagined. Something external could be influencing all this and causing these changes, or we may have overestimated our comprehension and still have much more to explore than we ever dreamed. Thank you for your company, and see you in the next video.